Hey, Marcia here. We've been talking about egg drop challenges and we've been talking about a damage predictor, momentum. So one of the last videos, I used conservation of energy to solve for the velocity as a function of drop height. And I proposed momentum as a damage parameter, which is a function of mass times velocity. So with our initial egg drop test, we clearly showed that when we raise the egg to 7 or 8 feet high, we do a lot more damage than we do when we raise it to only 2 inches off the ground. And we saw increased damage as a result. Didn't we, Mooney? Yeah. Okay, but that's the velocity piece. What about the mass piece? Well, I can do a quick experiment to show you that if I raise a heavy exercise ball the same height as this little tennis ball and aim it at a flimsy cardboard box, what do you think is going to do more damage? So we can test that mass is also a good predictor in the damage equation. And Mooney's all about the balls. So I'm going to break away, do that, and then come right back. Okay, so I have to aim this. Okay, so that moved the box, but not really any significant great damage. Here's another one. There's a little bit of a bend. Okay, and here's a heavier mass ball. Okay, quite a bit more damage. Okay, so my drop height may not have been perfect. I don't think I raised the weight ball quite as much, but quite a bit more damage. Just what we would expect from momentum parameter. Okay, so this may not be the perfect predictor of damage for all regimes because the velocity of your projectile can make a huge impact on the type of damage you're seeing. But for what we're doing with egg drop, it looks like it's a pretty reasonable parameter. Mass times velocity. So if we increase mass, we'll increase the damage, and we'll increase the velocity, we'll increase the damage. Now we use conservation of energy to solve these two energy equations for velocity. Conservation of momentum is also a principle. So where does all that momentum go? So we've got momentum equal m times v at the time of impact. We can solve for v. But where does it go? The velocity seems like it goes to 0, right? Well, if you remember dropping that egg from 8 feet high, and you looked at my crime scene photos, you saw that bits of shell flew all over the place. So small amounts of mass may get velocity going in other directions. Okay, so we maybe don't have pure v equals 0 after impact, but we have conserved our mass. So what else could we be changing? Now, usually when we think about conservation of momentum, we think about two cars colliding. And the faster car that hits the slower car, you know, somebody hits you while you're driving, they're going to create a jolt, and the combined momentum of the two cars has to be conserved. So usually that means the person in front that got hit from behind is going to speed up. And yeah, you're going to lose momentum with friction and dents and damage to the car. You're going to see some changes in momentum there. When you're using something like this concrete patio, that's basically this massive, you know, mass compared to a small egg, okay, the truth is we don't see major changes in momentum because the system we're colliding with is so big. So there may be, you know, microscopic changes to velocity at the top of the concrete where the egg hits, but the egg is getting most of the damage, and most of the momentum changes are occurring with the egg. So we're getting fracture surfaces, we're creating heat, there are changes of momentum in the microstructural content of the egg. Now, the other piece of the puzzle with the conservation of momentum question is that when the damage parameter is high enough, like a bullet from a gun hitting into a piece of brick, even though you have this massive wall, you can see chips come out of it. So conservation of momentum does apply. We may not easily be able to see the effects because we're working with a fairly, what we'd call a fairly slow system. We're not at ballistic impact ranges, huge strain rates. So we probably are not going to see anything massive happening to our impact target. But what we do see is going to depend on the speed and the energy of our projectile and also the strength of our impact surface. So in some cases we will see impact damage, but for egg drop, probably not.